Okay, so now we're going to go and work some examples from section 2.1. Just like before, I went ahead and put some of the answers right here just so we know if we're doing our work right. Sorry about the handwriting. Yeah, as you guys all know, it's kind of hard to write on the chalkboard. But here we have 7 plus z is equal to 11. So anytime you see this and we see the term solve for the variable, we got to identify the variable, which is usually a letter or a symbol, and we got to solve for it, find the value. So the first thing we know we want to do is we want to collect like terms. Since like terms are collected on both sides, then what we do is we want to get the variables on one side, the constant terms on the other. So the variables are already on the left. Let's keep it here. We got to get this constant to the other side. The way we get the constant to the other side is, okay, we got a plus 7 here. The way we get rid of it is through saying, okay, let's subtract 7 from both sides. So if we subtract 7 from this side, we can do that as long as we subtract 7 to that side. And one of the things I like to remember is always draw a line right there on where the equal sign is, and we can do anything we want as long as we do it to both sides of that line. So we subtract the 7 on this side as long as we subtract 7 on that side. Now we can go. Let's draw a line here. We know that 7 minus 7 is equal to 0 plus z. 11 minus 7 is equal to 4. Our equal sign just carries down. So now we have 0 plus z is equal to 4. We know the 0 we don't have to put. So we have finished. Z is equal to 4 is our answer. And sure enough, look up here. Z is equal to 4. Now the way we can check this, we just get this value, plug it into our initial equation. 7 plus, we said z is equal to 4 is equal to 11. Is this a true statement? Sure is. 7 plus 4 is equal to 11. So we're good. So we're going to go ahead and save this as some notes so I can include in the PowerPoint. And let's go ahead and do another example. Number 33 is going to be the next problem. Here we have a fraction. You treat fractions the same way. Remember, fractions are just numbers. So we have a variable on the left, a constant on the left, and just a constant on the right. So let's go ahead and draw our little line here all the way down, right? Whatever we do to the left, we have to do the right. So we want to get all the constants from the left to the right. Well, the way we get rid of 3/4 on the left is we subtract 3/4, because 3/4 minus 3/4 is equal to 0. We can do that as long as we subtract 3/4 from the right as well. So x plus 3/4 minus 3/4 is just equal to x is equal to negative 9/2 minus 3/4. Well, we know that when we subtract fractions, we have to find a common denominator. The common denominator here is going to be 4. So this is going to be x is equal to, so we get 4 here is multiply both of these guys top and bottom by 2. Negative 9 times 2 is going to be negative 18 over 4 minus 3/4. And when we subtract fractions, we just do the subtraction of the top numbers, and we know our answer is going to have the denominator of 4. Negative 18 minus 3 is going to give us a negative 21. So our answer is going to be x is equal to negative 21 over 4. What do you know? That's what was in the back of the book. So we have done this one right as well. And you can always check your work by plugging in negative 21 over 4 right here and make sure that the equal sign stays. So let's go ahead and save that one. Let's do another example. We'll go and work on number 47. Number 47 is a little bit, looks like a little bit trickier, but we'll soon find out that it actually isn't. we know the first thing we've got to do is collect like terms. And the way I like to do this is always start with my x values. We've got a negative 5x plus 2x plus 4x on the left. Negative 5 plus 2x is equal to negative 3x. Negative 3x plus 4x gives us just a 1x. Then we're going to have a plus 7 plus 8 minus 3 plus, oops, let's get rid of our x's. X's are gone, we just did those. Now we're left with 7 plus 8 is 15 minus 3 is 12. So x plus 12 on the left is what we simplify all this to, is equal to, we got a 2 plus a 3 times 5. Well, remember from order of operations we got to do multiplication first. So 3 times 5 is 15. It's equal to 15. Let's put a little note up here. And now we just add 2 plus 15 is equal to 17. So now we reduce all this thing to just this simple equation. X plus 12 is equal to 17. Again, we just apply the same rules. We want to get a variable by itself, so we can take all the constants from the left to the right. We can do this as long as we do the exact same thing to one side as we do to the other. So we subtract 12 from this side. We know that 12 minus 12 is equal to 0. We're left with x on the left is equal to, now we've got to subtract 12 from this side as well. 17 minus 12 is equal to 5. So our answer is x is equal to 5. And sure enough, that's what we got here. Now again, we can do the same thing and check our work by plugging in the value of x equals 5 into our first equation, and we'll find out that indeed it is the answer, because the equal sign will be true. Let's go ahead and save this guy. And according to my time here, I'd like to do one more, and then maybe, actually, you know what? We'll go ahead and stop here, and I'll complete the last two examples on the next video.